Good afternoon, everyone. And actually, I don't know much about housing, but when I listen to the previous talk, I can see that our requirement and preference change over time. So for the elderly people, as you said, that you prefer one-story house. But last time, last year, my wife and I were looking for our first house, and she insisted that we have to buy a two-story house because she said that whenever we have an argument, then we can sleep on different floor. I'm actually a computer scientist by training, and my research focus on learning and recognition in computer vision. And for that, I'm working a lot with images, video, and machine learning. But so one of the main line of research directions that I'm working on is early event detection. Now, there are many different situations where early event detection could be very useful. For example, elderly people have a high risk of falling. So if we can detect the falling event even before it happens, then we can deploy some technology such as maybe wearable airbag, and in this case, early detection would save a life. Okay, so here's another situation where early detection might be important, and by early detection I mean to detect an event even before it is complete. Okay, if we detect the event after it has finished, then maybe it's already too late. Now, for elderly people, I suppose there's some actions that might be dangerous for them to attempt to perform. For example, in this case, I don't know, maybe you can already understand or see what the person is trying to do. I would say this type of action might have a high risk of falling and hurting their back, right? So one of the questions that we want to do is whether we can build a smarter home. And by smarter home here is basically we meant like if we can have some instrumented sensor or camera to figure out and predict the intention and the activity of the person here. So whether, suppose we have a camera, and can we predict what the person is trying to do? Is he trying to, try to reach and grab something on the top shelf? Maybe there might be some warning or something to alert her to stop doing the action, otherwise she or he might fall. Now, in order for us to actually detect the action or like early detection of the action before it happens, the research question that I'm interested in is here is a sequence of a video sequence of a person doing some action, and in the middle there's an event that the person is performing. But actually, at some point, like at the the vertical look. Oh, sorry. Yeah, the vertical location here is when where I do the boundary between the past and the future. And at that time step, what you already observe is the person is trying to do the action, but you don't really observe this part of the action. So at this point, we look at a lot of existing event detectors, and we see some limitation of them. First of all, at this time step, there are two options that one can do. Either you delay making the decision until you see the full action, or the detector can try to make the decision right there and settle for unreliable decision because the detector wasn't trained to kind of recognize the partial event. Okay. Now, actually, there's some other questions that we need to answer if we want to build a system that can understand human intention and predict what he or she is trying to do. First of all, in the house, there are furniture, so if you just use a single camera, it might not have enough coverage for the house. So you might want to think about using multiple cameras to cover, or multiple sensors to cover the entire area. And typically for this camera to talk to each other and to analyze the camera, they need to be connected to a processing unit or a server. Maybe some camera can be like hardwired to the server, but some further camera can be communicated through the Wi-Fi or some wireless channel. But the problem with the technical problem that we face here is the camera cannot be analyzed at the same time because the network has limited bandwidth, so you cannot really transfer all the video images at the same time to the server. And even when you can, the server can receive all the images, it cannot really, it might not have enough processing power to analyze all of them at the same time. So the technical problem and the way that we formulate in this case is the task what we want to do is we want to recognize human action as early as possible, recognize action even before it is complete. And we want to use multiple observation streams from multiple camera, but not all camera can be accessed at the same time. So in order to solve the problem, we need to address several technical research questions. And the first one is how do we recognize an action even before it's complete? How do we make decisions based on partial evidence here? And when we have multiple cameras, which camera should we choose to use at each time because we cannot use all of them at the same time? And for the camera where we cannot really look at it or analyze the images, how do we handle missing observations? And finally, how to combine information from multiple views. So these are the technical questions that in my research I'm trying to address. So in this talk, I don't have time to go into the detail of how I actually address the problem, but I'll give you some overview of the main approach that we are using here. So, the basic approach that we use is we treat a system of multiple camera as an intelligent agent, where the agent needs to make a decision at every single step, and the decision the agent needs to make is, to predict or to recognize what activity or action is occurring. At the same time, the decision the agent needs to select what camera to analyze at each time step. So this is a sequential decision process, and we formulate this as a partially observable Markov decision process. Basically, it is like we kind of associate the agent to receive some certain reward when they make a decision, and the reward of the agent depends on how early and how accurate the system can make and can recognize the action. All right. There's some other. Okay. Right. All right. So here's the. Okay. Let me just keep talking about it. But here's how we actually model the system. So basically, at every time step, the system going to receive input from multiple camera, and there's some internal state that accumulate information from the past. And at the same time, it also tries to make the prediction, which is what actually occurring. And here is in math, in machine learning, we call it a recurrent neural network, which is a deep network that try to analyze the sequence of information and try to make the decision. And this deep network has two functions that we need to learn, which is basically how to update the information, how to aggregate the information over time, and how to make the decision based on the state information. But this problem is well studied in machine learning and also in computer vision. But one of the things that they didn't really study very well is and which actually happened when we try to apply the technology into building smarter home is because, if we have a camera at home where we experience delay in communication and if we have limited processing power, then we don't really have very nice video stream. the frame rate is lower than what we would normally get if you have a camcorder and you record the video offline, right? So there's missing information that we need to handle. And because of that, what if, so one of the research questions that we try to address is how do we handle missing frame and missing information in a video stream? So one approach is to skip the update until the next observation, but this approach normally doesn't work very well. So part of my research is to come up with a technique to address this technical problem. Okay? All right, I'm going to skip this. All right. And yeah. All right. Let me. Okay. So we actually have a technical solution for all of the problems that I knew about. And let me just explain for you one of the pilot studies that we performed. Now, what we did, we take the NTU's IGBD data set, and this is a data set with about 40,000 video clips collected with 3 Kinect camera from 3 views. And this data set had about 40 subjects, and each subject performed about 60 action classes. And the type of action classes that considered in this data set is among the 60 action class, 60 daily action such as drink water, brush teeth. There are 9 health-related actions like falling or vomiting condition, and then 11 mutual action of 2 people, example like handshaking or pushing each other. When we develop the technology and then apply on this data set, this is the type of results that we get. Now, what I'm plotting here is basically the recognition accuracy over time. And on the horizontal axis, you get to see what we call the observation ratio. The observation ratio means if it go from 0 to 1, 1 means that you already the full event already happened. 50% means that only 50% of the event already happened. Okay, so the more you've seen of the event, the easier it would be to predict or to recognize that particular event. So when you try to build a detector, you can have a trade-off. Now you can make a detector that recognizes things very, very fast, but at the same time, you can have very high false positive rate. On the reverse side, you can have a detector that never detect anything, so it have the precision very high, but at the same time, there's a lot of delay in making the decision. So inherently, the trade-off between the amount of information, how much you should wait, and how accurate you want the detector is. Okay, so this plot shows the trade-off between these two criteria or 2 things that we want to optimize at the same time, basically. Well, the bottom line here is we have a method that works well better than the competing methods that we tested with, and you can also see that how well it works right now. Like, so the accuracy when you see the full event or the full action is around 70%. And here, 70% might not sound like 90% or 99, but it's already pretty good, given that we have 60 different classes. So the chance is 1/60 if you want to put it that way. So recognize the accuracy rate of 70% is pretty good. In my area, we consider it pretty good. But of course, there's a lot of room for improvement. Right. Okay, there's a lot of other things that we compare with, but let me skip them and talk about. Now, so at Stony Brook here, we are building a lab that we call Home of the Future, where it's a 1-bedroom apartment with bedroom, kitchen, and bathroom. And the layout is pretty much like the diagram that you see on the screen here, where there's a bedroom, there's a sofa, a dining area, and a TV. And this is what it looked like in the real image of what it looked like here's my students, but you can see at the corners there's one camera like looking at the living area, and to see how the camera looks like. On top of the TVs, there are 3 cameras looking at 3 different directions here. And in total, we have about 8 Kinect cameras around the apartment. And we also have the camera in the bedroom too, the 2 cameras. This is 1 camera, and this is another one at the opposite corner. And you can see that we're still trying to setting it up because you look at the bed is there, but there's a lot of junk on the thing. Right. Now, so what I want to do with this, like I want, so we have a pilot study. We collect, we use the data that collected by other places, but we want to do something more realistic scenario for aging population. And the data of our pilot study is, it's realistic, it's real, but it's not as realistic as we want it to be. So to do that, we need to, to consider more realistic situation. And what we want to do next is to collect some data for this purpose. When we're thinking of bringing about 20 to 30 subjects and perform some of like 10 to 20 action or activity categories here. So what I'm looking for from this audience here, first of all, I want some inputs about like what are the typical daily action for elderly people, important action categories that we should study, what are the type of things that you would like, the ability to predict, or if we can predict what you are about to do. How does it help you, and what type of action would be useful? So I myself don't know. I can I can try to think about particular scenario, but that might not be a realistic thing that elderly people actually care about. I'm also looking for collaborators to help define and shape our study. People who know the real and important problems, and who can communicate and recruit elderly people subject, and also involve the communities. And of course, we're also looking for funding opportunities for this project. Right now, we have some startup money. I have some startup money, and we still need to work on it. But for sustained project, I would need more like a different, more stable funding source. And that's it. Thank you.
I guess privacy.
Yes, of course. Privacy is always a concern. I myself have a camera at home, and I have concern too. But this is something that I would, I know it's a big problem, but it's not something that I can address. So I would dedicate it for other people to address this issue.
So can I ask something? For
these cameras, like for instance, when they are scanning people in the Air Force and everything, they use still visualization, but they have some body shape, but not necessarily all the details. Like, then is there such possibility to use similar techniques? Of course, I'm assuming accuracy will be lower, but different kind of cameras to do the same job.
I think that's a good direction, interesting. I think all we need is kind of skeleton of the person. We don't really need to see the face. I know some company build, like for example, the iRobot with the vacuum, they have the camera, but you cannot really access the camera. So they do use camera to see something, but they are encrypted, so you cannot really hack into it to see it. So with the right companies, they may be able to produce a style camera.
Any questions?
Just a comment, a couple of suggestions for thinking about what kinds of activities you might want to look at. I know occupational therapists often evaluate aging adults in their own home situation, and they look at activities of daily living and instrumental activities of daily living. And there's a whole literature on that, and maybe offline I could point you to some of that. And then the other suggestion is that at the University of Michigan, where I'm from, they've just finalized development of a home lab, which is very similar to what you've done. And I know they've been giving a lot of thought to the kinds of scenarios that they want to look at. So maybe there's an opportunity for some communication or collaboration there. And the head of that lab is Rich Gonzalez at the University of Michigan.
Oh, okay, thank you. Yes, I will follow up with you.
I'll follow up with you.
Have you thought about using the Kinect? Because that's what most of the aging in place people use.
I'm sorry. what-
Kinect?
Kinect. We are using
Oh,
Kinect.
okay, okay.
We have Kinect, but at the same time, the bandwidth of Kinect is huge. So that's why there's a lot of problem with the delay in processing the stream of Kinect too.
NSF funded the QUALT Center, Quality of Life Technology Center in Pittsburgh. It's between Pitt and CMU. And I remember that they were doing a lot of, it was mainly around robotics, but they were doing a lot of trying to get the robots to understand things like intentions of humans that they would be working with. And they built up a lot of public libraries for categorizing human activities, and those might be a good source to go to look at things that people have done already.
Yes, absolutely. My PhD was funded by Quality of Life too, so I was from there. So I do.
Yeah, so you're familiar with them, with some of the libraries they have?
Yes. Yeah.
Okay.
Well, not maybe not very recently, but.
You know, 2 years ago here, when at the previous conference, a year ago October, that inspired this one, we talked about a solution that was vital, which is, and that at the time everybody felt was doable, which is trying to put access to things people could get on their computer on the television screen. So that people who do not know how to use the computer could use their television remote controls to access things and services they need. It seems, you know, we have a gap here until everybody catches up in technology. We're going to have a gap with one generation. And it would seem like that's a project to focus on.
To access the information through TV screen.
Right.
Well, right. I see. Well, I know people in the computer science department actually work on this area, but this is not my area of expertise, so I don't know whether I should. I'm qualified to comment about it, basically. But I agree that people are much more familiar with using the TV remote than the mouse. Therefore, yes.
Any more questions? Thank you. Then this also.